This is video 9A for the Year 8 Mathematics course. In this video, we're going to be covering the theory behind circles under the topic of plane geometry. Specifically, we are going to explore the definition of a circle, the anatomy of a circle and important terminology, and then we're going to cover some example questions. Alrighty, let's talk about circles. Specifically in this video, we're going to first of all give a very formal definition for what the shape defined as a circle actually is, and then we are going to break down every bit of a circle that we possibly can and define all the important terminology related to circles. So, of course, we've all seen a circle before. What is the actual definition of a shape called a circle? Well, a circle is a two-dimensional shape such that all the points on this shape are the exact same distance from a common point, which we call its center. So this is the very formal mathematical definition of a circle. It's a two-dimensional shape such that every single point on the shape has the exact same distance away from the circle's center. Now, of course, we know that a circle looks something like this. Ignore my very rough artistic abilities there. But what we know here is that if I represent the circle's center using this dot here, then what this therefore means is that if I draw a straight line from the center to any point along the actual circle itself, so any of these lines here, then all of these lines are going to have the exact same distance. And this is indiscriminate to whatever point we have on the circle. So again, it could be this line here, this line here, this line here. Any distance from this center to any point along the circle itself has the exact same distance. Now, of course, we probably already knew this. It's one of the most fundamental aspects of any circle, but it's good to give it a very formal definition. Now, with that being said, let's get into the actual anatomy and some very special terminology when it comes to circles. Alright, so the first thing that we're going to define here is something that we've probably heard of before, which is what we call a radius. Now, formal definition of a radius is a line segment that connects the center of the circle to any point on the circle. So if I just quickly draw up a circle here, if this here is the circle's center, then the radius could be this line here, this line here, this line here, that line there, that line there, that line there, and so on. And it really doesn't matter because as we've already just established, every single one of these line segments will have the exact same distance as per the actual definition of a circle. So all of these line segments are of equal length. Now, whilst we define the radius as these actual line segments themselves, it's important to understand that moving forwards, whenever we refer to the radius of a circle, we are typically referring to the actual length of these line segments. In other words, from here on out, whenever you hear the phrase radius, what we're actually saying is what is the distance between the circle's center and any point on the circle. Alright, so that's the radius. We now have something called a diameter, which of course we've probably heard of before. Formal definition of a diameter, This is a line segment that connects 2 points on the circle, but it also must pass through the center. So once again, if I just draw up a rough circle here, if the circle's center is at that point there, then the diameter could be this line segment, this line segment, this line segment, this line segment, and so on. But what we notice is that every single line touches 2 points on the circle, and they all pass through the circle's center. And the really cool thing about the diameters is that much like the radii, they are all of equal length. So in other words, this line segment has the same length as this line segment, which has the same length as this line segment, which has the same length as this line segment, and so on. And the reason being is because, as we should probably notice from here, the diameter is more or less just two of the radii connected together. If we just consider this diameter here, then we can see that this part here is a radius, and that this part here is also just a radius. So each diameter is effectively just two radii connected together. Now, much like the radius, when we are referring to the diameter from here on out, we are often referring to the actual length of the line segments themselves rather than them being the actual line segments. So what we'd say from here on out is that the diameter of this circle would be the length of whatever this line segment is, or again, whatever the length of this line segment is, or this line segment, or this line segment. But they all have the exact same length, so it doesn't really matter which one we're referring to. Or in other words, from here on out, we're now going to be referring to the diameter as the distance between any 2 points along the circle that also passes through the center. And because of this, we can therefore say that the diameter is equal to 2 times the radius. Okay, so that was the diameter. Let's move on. We also have something called a chord. Now, the definition of a chord is simply a line segment that connects any 2 points on the circle. So for example, if we have a circle that looks like this, a chord could be this thing here, this thing here, this thing here, this thing here, or whatever. But again, the key thing here is that any chord has to just touch 2 points on the circle. So this chord here touches these 2 points, we've got these 2 points, we've got these 2 points, and then we've got these 2 points. There are no other restrictions. And so therefore, what we can effectively think a diameter as is just a special type of chord, because we know that diameters touch 2 points on the circle, but they have the added restriction that they must pass through the center, whereas chords just have to touch 2 points on the circle. Alright, moving on, we now have something called a semicircle. And effectively, a semicircle is just half of a circle. Specifically, if I were to draw out this circle here with this center here, then we could define a semicircle as the following 2D shape. So this part here. Because all we want is we're going to draw a diameter, which is what we did with this straight line here, and then we just take 1/2 of the circle itself, which therefore means that the radius of a semicircle is still the same, and the diameter is still the same as well. but we only consider half of that circle. Next up, we have something called an arc. And an arc is any part, or in other words, fraction, of the circle's perimeter. So for example, if I draw up this circle here, then what I could do here is I could draw part of this circle. This here is an arc, or this here is an arc. This here is an arc. That there's an arc. This thing here is an arc. So any part of the actual circle outline itself. Next up, we have something called a segment. And a segment is defined as the region between a chord and the circle. So again, let me draw up a rough circle here. So if I were to draw up this chord here, or this chord here, or this chord here, and so on, then we would define a segment as this region here for that chord, this region here for that chord, or this region here for that chord. But it's all about drawing up a random chord and then just taking the area between that chord and the circle itself. Alright, final two. The next one that we're going to consider is something called a sector. And a sector is defined as the region between two radii. So what do we mean by this? Let me draw up a circle over here again. If I were to draw up two separate radii, so it could be this one and this one, or it could be that one and that one, or whatever, then what we now realize we've done is we've effectively segmented this circle into smaller parts. So this thing here would be classed as a sector. This thing here would be classed as a sector. This thing here is a sector, and this thing here is also a sector. So moving forwards, typically when we're working with sectors, we're mostly concerned with the actual area of these sectors, but we'll get into that in a future topic. Alright, final one that we're going to talk about is something called a tangent. And a tangent is a straight line that touches the circle at one point, but doesn't actually pass through it. So again, let me draw up a circle over here. So an example of a tangent could be something like this, or something like this, or something like this. But what we notice in all three of these situations is that the tangent, or in other words, the straight line, only has one point of contact with the circle. With this one, the point of contact is here. With this one, point of contact is here. With this one, point of contact is there. So it doesn't actually pass all the way through the circle. It touches it at one point and then just continues along the outside. Now, the really nice thing about tangents, and this is a property that we're going to be using quite a bit in the next few years as well, is it turns out that if you were to draw a radius to any of these points of contact here, so in other words, this line segment, or that line segment, then the tangent and the radii always meet perpendicularly. Or in other words, they always meet at right angles. So this angle here is a right angle. This angle here is a right angle. This angle here is also a right angle. So as we move into future topics as well, as I mentioned, this here is a very, very, very important property that we'll be using quite a bit, especially considering we use right angles quite a bit in Pythagoras' theorem and in trig as well. So this here will definitely come up again, but for now, all we need to be aware of is that tangents are straight lines that touch the circle at one point, but they don't actually pass through. And furthermore, they always meet the radii at right angles. Okay, so those there are the key bits of terminology and the overall anatomy of a circle. It's very, very important moving forwards that you do understand each of these different parts very, very clearly. So for example, if I ever refer to an arc, you should know what an arc is. If I refer to a segment, you should know what a sector is. Same with radius, diameter, chord, semicircle, tangent, and so on. So really, this particular topic here is all about understanding the anatomy of a circle. Once you fully understand all these different parts, then you are good to go for the future. Now, all we're going to be doing for a few examples here is just classifying a few different parts of the circle based on what we've just talked about there. So I'm just going to draw up 4 quick circles, each of which are going to be representing different parts, and then we're just going to classify each part. Alrighty, let's look at this first one here. So what we can see that we've got here is a line segment that connects the center of the circle to a point on the circle itself. We of course know that this here is a radius. Next one, what we have here is the region of a circle between 2 different radii. We know that this thing here is what we call a sector, or in other words, a part of the actual circle's area. Next one, here we have a straight line segment that touches 2 points on the circle, doesn't necessarily pass through the actual circle center, so we call this here a chord. And then finally, what do we have here? We have a straight line that touches the circle at one particular point, doesn't actually pass all the way through it, but more importantly, this line here meets the radius at right angles, which means that this line must be a tangent. Alrighty, let's summarize what we've learnt today. So in this video, we delved into the definition and anatomy of circles. Circles are defined as a shape such that all points are equidistant from a singular point, which acts as the circle's center. We then considered the following terminology related to circles. Radius, a line segment that connects the center to any point on the circle. Diameter, a line segment that connects 2 points in the circle and passes through the center. The diameter is twice the length of the radius. Chord, a line segment that connects 2 points on the circle. The diameter is a special type of chord. Semicircle, a half circle cut at the diameter. Arc, any part of the circle's perimeter. Segment, the region between a chord and the circle. Sector, the area between 2 radii. Tangent, a line that touches the circle at one point but doesn't pass through the circle. The tangent is perpendicular to the radius at the point of contact with the circle. We then applied this terminology to classify different parts of a circle. And that's it for now. See you in the next video.